Okay, Trig kids, I finally got my new headset wireless mic in, and so hopefully you can hear me a lot better. I am going to continue with section 7.1 notes. There's a couple of real doozy problems in here, so hang with me, okay? Starting with what would have been my problem 15. Again, this is section 7.1, part C. Okay, problem 15. I have cosine x over secant x plus sine x over cosecant x. Now, just like I said in the previous recordings, we really need to rewrite each trig function that we can in terms of sine and cosine, and then try to reduce everything. So secant, remember, is 1 over cosine, and cosecant is 1 over sine. So we're going to have a little complex fraction on both sides here. Okay, now I am going to solve each side kind of separately. Remember, a complex fraction, the big fraction bar is nothing but a division symbol. So this is going to be cosine x times cosine x over 1, because remember, if we divide by 1 over cosine x, we multiply by cosine x over 1, plus sine x, that's in my numerator there, times sine x over 1. Again, big fat fraction bar is a division symbol. We divide by a fraction, we multiply by its reciprocal. So I just flipped the bottom when I multiplied. So this is going to give me cosine squared x plus sine squared x. And once again, I want to write up, I'm going to write this so many times you guys are going to have it stuck in your memory forever, but I'm going to write up the trig identity, the basic one that comes from Pythagorean's theorem, which is sine squared x plus cosine squared x equals 1. Again, your basic Pythagorean theorem trig identity. So if we have cosine squared x plus sine squared x, obviously that also equals 1. That is simplified. Okay, moving on here. Now, number 16, you'll probably notice in your homework, if it's like mine, that it's one of those step-by-step ones. They want you to fill in the blank. Well, not knowing what everyone's problem looks like, I'm just going to verify the identity just normal. And you can figure out what goes in the blank. But again, they're kind of baby stepping your way through it. So I will also kind of baby step my way through this one. So the problem I have is sine beta plus cosine beta times cotangent beta equals cosecant beta. So here we go. Okay, and don't let the beta fool you. That's, again, it's just one of the Greek letters like theta is. They use all kinds of Greek letters in higher level math, so don't let that fool you. If you want to switch it to x while you're working out the problem, fine. But keep in mind, when you're putting it in WebAssign, you need to use the same variable. So otherwise, they're going to count it wrong. So just be aware of that. So first thing I would do is turn, I'm just going to kind of be working here on the left-hand side only. Okay, I'm not going to look at this as an equation. I'm looking at it as I am manipulating or simplifying the left-hand side to get it to look like the right-hand side. Okay, so I'm not really solving this like a traditional equation. So I'm just simplifying the left-hand side. So on the left-hand side, the only thing I can really substitute in is the cotangent, or replace the cotangent beta with cosine beta over sine beta. Because remember, cotangent is cosine over sine. So that's where I'm going to get started here. So on the left-hand side, I would replace again cotangent beta with cosine beta over sine beta. Okay. Now, what I need to do is remember I've got this plus sign here on the left, so it's like I'm trying to add two different terms. Well, in order to add two things when we've got a fraction here, let me go ahead and write this next step. This is like cosine squared beta over sine beta. Now, remember, to add fractions, you got to have common denominators. So I've got to multiply this one over here by a sine beta on top and bottom. Okay, so if I'm multiplying by a sine beta on top and bottom to get common denominators, then I'm going to end up with sine squared beta over sine beta plus cosine squared beta over sine beta. Okay, now since they have common denominators, then I can combine them into one fraction. So this is sine squared beta plus cosine squared beta all over sine beta. And again, you gotta love the dead spots on my board, but you get the idea here. Okay, so once again, that trig identity rears its head. What does sine squared beta plus cosine squared beta equal? It equals 1. That's the trig identity, remember? So this is 1 over sine beta, and 1 over sine beta is the trig function cosecant beta. That would be your final step here, and that proves or verifies the identity. Same thing. Okay? That's what we were trying. We were manipulating the left-hand side to get it to look like the right-hand side. Okay, that's what they mean when they say verify the identity. Okay, moving on to the next one. This would be my number 17. I have 1 minus cosine beta in parentheses times 1 plus cosine beta equals 1 over cosecant squared beta. Okay, so first of all, 1 minus cosine beta times 1 plus cosine beta equals 1 over cosecant squared beta. Now, once again, just like in the last one, I'm not worried about the right-hand side right now. I'm not solving this like a traditional equation. I'm trying to verify the identity, which means I'm trying to manipulate the left side to where it, manipulate and simplify, maybe I should say, to where it looks like the right side. Okay, so on that left side, I have two binomials, and those binomials actually are the exact same except for the middle sign. So this is kind of like the difference of two squares in reverse, if you will. So really, if you want to think about it as foiling. So we're going to do first, outer, inner, last. Well, if you remember, when you FOIL two binomials that are the same first and last terms and all that's different is the inside sign, the outers and the inners are going to cancel. All we're going to end up with is 1 squared minus cosine squared beta. Okay, So you square the first term minus the square of the second term if you FOIL it. Okay, that's essentially what we're doing is we're FOILing. All right. So 1 squared minus cosine squared beta. Well, obviously 1 squared is just 1. Now, once again, does that kind of ring a bell with our trig identities? Okay, remember trig identity one more time. We've got cosine squared x plus sine squared x equals 1. So if I move my cosine squared x over to the other side, then sine squared x equals 1 minus cosine squared x. Okay, that's the trig identity. So 1 minus cosine squared beta would end up giving us sine squared beta. Okay. Now, sine squared beta, think about your reciprocal identities. Okay. If you look back up at the first step, we're trying to get the left side here to equal 1 over cosecant squared. Well, that's what cosecant is 1 over sine. So the reciprocal identity, this does equal 1 over cosecant squared. Again, these are the same thing. That's what we're doing. Okay? Sine is the inverse of cosecant, or cosecant is the inverse of sine. All right, this was another like baby step one. Okay? So you've got to fill in the blanks on the steps on your homework. Now, number 18 is a doozy. All right. I'm going to skip it for a minute and come back to it. All right. I'm going to skip, well, yeah, I'm going to skip it and move on to 19, which is much easier. I'm going to actually probably make 18 its own little video. It can get kind of hairy. So hang with me. Let's do number 19. Now, you'll notice starting with number 18 on your homework that they say to verify the identity, and it just says to show your work. They just give you a box to type in. You are going to have to type out these steps. I will be looking at this, and more importantly, Jim Paprick from Missouri Valley will be looking at this. And so you need to show the steps like I would be writing on the board. Unfortunately, you're going to have to type them out. So it's going to look kind of ugly. I get it. Just do your best on the typing part. Okay? And you can write it kind of in paragraph form, or you can, like kind of what I do when I write it on the board, type out a line and then hit return to go to the next line. Okay, to kind of prove you're going step by step down, if you will. So however you type it, I don't care. Just make sure it makes sense, and make sure that if you're using like your slash instead of formatting it like a fraction, that you're going to use parentheses. Okay, so that I know it's supposed to be a fraction. So again, I'll be looking at these on your submitted homework, and more importantly, Jim Paprick will as well. So these problems of this section will have to be hand graded. Okay, so again, this is problem 19. So my problem 19 is secant x minus cosine x equals sine x times tan x. So okay, thankfully we're back to x's now. I don't like using betas. Okay, so remember, well, there's a couple different ways we can do this one. I actually kind of prefer, well, no, we're going to do it the same way I did the last ones. We're just going to kind of manipulate the left side for right now. We can also, on the right side, go ahead and substitute in for tangent x. We can substitute in the sine over cosine. So it kind of depends. When you go to verify an identity, sometimes you just work with the left side, which is usually the case. Sometimes it can be a little easier if you go ahead and manhandle the right side a little bit. It just kind of depends on the problem. So let's start here on the left-hand side. First of all, just like normal, I'm going to write what I can in terms of sine and cosine. So secant, remember, is 1 over cosine. So 1 over cosine x minus cosine x. Now, again, in order to get common denominators here, if we're going to add or subtract fractions, we've got to multiply this one by cosine x over cosine x. So now I'm going to have 1 over cosine x minus cosine squared x over cosine x. Now that I've got common denominators, this is just 1 minus cosine squared x over cosine x. Now, 1 minus cosine squared x. I'm not going to write that trig identity up again, but the sine squared plus cosine squared equals 1 is that basic trig identity. So that means that 1 minus cosine squared x is sine squared x. Well, sine squared x over cosine x, okay, I can pull a sine out of the top. This is sine x times sine x over cosine x. Well, isn't sine x over cosine x tangent x? So this is sine x times tangent x. Same thing. Again, verify identity. Okay, you're trying to get the left-hand side, manipulate it to where it looks like the right-hand side. Okay, that was number 19. Again, just a reminder, we're coming back to 18 in a minute. Number 20. Number 20, I have sine to the 4th theta minus cosine to the 4th theta equals sine squared theta minus cosine squared theta. Now, the hint I'm going to give you on this one is difference of two squares. Remember your difference of two squares formula. Your difference of two squares formula, if you remember, if you have a squared minus b squared, that equals a minus b times a plus b. Okay, by the same token, if I take that up a notch, if I've got a to the 4th minus b to the 4th, that would be a squared minus b squared times a squared plus b squared. Okay, so this right here is the basic formula for the difference of two squares, but a 4 is also a perfect square. So a to the 4th minus b to the 4th would be a squared minus b squared times a squared plus b squared. So that's what we're going to use here on the left-hand side of our trig problem. So sine to the 4th theta minus cosine to the 4th theta would factor down to sine squared theta minus cosine squared theta times sine squared theta plus cosine squared theta. Well, once again, that stinking trig identity keeps cropping up. What does sine squared theta plus cosine squared theta equal? This whole thing equals 1, our trig identity. That's the basic one, okay? So this just gives me sine squared theta minus cosine squared theta times 1, which is, of course, now you'll notice this is what's left. This was what was on the right-hand side. Those are the same. We verified that trig identity. Okay? Difference of two squares formula. Okay, number 21. and then we'll go back to 18, which is kind of a beast. So number 21. I have 2 sine squared x minus cosine squared x equals 3 sine squared x minus 1. Okay, making sure I wrote it down right. Correct. Okay, now, this one I looked at for a minute or two before it hit me. Since the right-hand side of my equation is in nothing but signs, what occurred to me is that I need to manipulate the left-hand side to get it all in terms of signs. So the only way I know to do that is to substitute our trig identity in for cosine squared. So cosine squared, this part is going to become 1 minus sine squared x, and that is using the trig identity. Cosine squared x is going to become 1 minus sine squared x. Okay, and that's using our trig identity. So the rest of the left-hand side here, 2 times sine squared x and the minus are still there. Again, I used the trig identity. Okay, so now this negative has to be distributed, remember, to both terms. So this becomes 2 sine squared x minus 1 plus sine squared x. Okay, well now we've got 2 terms that have a sine squared x in them, so I can combine like terms here. So my like terms gives me 3 sine squared x minus 1. And that is, of course, the same as the right-hand side of my verify the trig identity problem. Okay? All right. Now, back to number 18. It's kind of a doozy, and I keep looking at it wondering if there is an easier way to solve this, and I'm not sure there is. So, here we go. Number 18. First thing, let me write down my problem. My problem is cosine x plus sine x, that binomial to the 4th power, equals the binomial 2 cosine x sine x plus 1 squared. So, okay, here's what my problem is. Now, this gets tricky. We literally have to multiply out both sides of the equation. I'm not going to spend a whole lot of time doing that because I'm going to use the binomial theorem. Don't know if you all remember the binomial theorem. Let me jog your memory here. Binomial theorem, we learned it in Algebra 2. I believe it was Chapter 6. Binomial theorem. Binomial theorem says that if we have like a plus b to the n, here's how you calculate it without having to multiply it all out. N choose 0, a to the n, b to the 0, plus n choose 1, a to the n minus 1, b to the first, plus n choose 2, a to the n minus 2, b squared, plus, and you keep going with that until you get n choose n, a to the 0, b to the n. Now, you guys are probably going, what the what? We did actually do this in Chapter 6 of Algebra 2. So I'm going to kind of jump ahead and use the binomial theorem on the left-hand side. Also, binomial theorem, if you remember Pascal's triangle, Pascal's triangle, if you remember, starts with the 1, and then 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I don't know if any of this rings a bell. If you remember, this was row 0. This is row 1, row 2, row 3, row 4. Row 4 is what we need for the fourth power for our binomial theorem here on the left-hand side. So that 1, 4, 6, 4, 1 is going to be the numbers that we replace n choose 0, n choose 1, n choose 2, all the way to n choose n. So 4 choose 0 is a 1, 4 choose 1 is 4, 4 choose 2 is the number 6, 4 choose 3 is the number 4, and 4 choose 4 is the number 1. So I'm going to use those. So you guys, I hope I didn't lose you, but if I did, hang tight. So this left-hand side, here's what the left-hand side. Actually, I'm going to put left-hand side, LHS, okay? So here's what I'm left with here on the left-hand side. I have cosine to the fourth x plus 4, cosine cubed x sine x plus 6, cosine squared x sine squared x plus 4, cosine x sine cubed x plus 1 sine to the fourth x. I know, it's really ugly. That's just the left-hand side if I use the binomial theorem. If you remember on the binomial theorem, your first term starts at the highest degree and goes down a degree each term, and your second term in the binomial theorem in the parentheses starts at a 0 power and goes up by a power each. So you'll see the pattern there on the cosine goes from 4, 3, 2, 1, nothing, to the sine goes from nothing, sine to the first, sine squared, sine cubed, sine to the fourth. Okay, now, right-hand side. This got a little tricky because what I ended up doing on the right-hand side okay, right-hand side. I am going to replace that 1, okay? So let me rewrite it first of all. So we've got 2 cosine x times sine x. I am replacing that number 1. Since I don't have any single numbers on the left-hand side here, I'm replacing that number 1 with that trig identity, cosine squared plus sine squared. Okay, so this part right here was the number 1, and I replaced it with the trig identity. Okay, and now the whole thing needs to be squared. So if you square all of that, here's what you get. Are you guys ready for this? It gets ugly as well. So here we go. We get on the right-hand side 4 cosine squared x sine squared x plus 4 cosine x sine x plus cosine to the fourth x plus 2 cosine squared x sine squared x plus sine to the fourth x. Whew. Okay, now that's just the right-hand side. If I multiply it all out, that is what I end up with, okay? I know this is ugly. Once again, hang with me. Now, since we have right-hand side and left-hand side up there, let's start canceling out common terms that I know will cancel out from both sides, okay? So that's going to be a blessing in and of itself. First of all, though, let me point out that this and this is a common, or a like term, I should say. So that would give us 6 cosine squared x sine squared x. So now let's start canceling. So first of all, cosine to the 4th x will cancel with that cosine to the 4th x. Again, we're talking left-hand side of the equation, right-hand side of the equation. Also, sine to the 4th x will cancel with sine to the 4th x. Okay? Also, the two terms that I just combined here on the right-hand side, the 6 cosine squared x sine squared x, okay? This cancels with that, which means that this goes away and this goes away. Woohoo! So this isn't quite as bad as we thought. Now we are down to just 3 terms, 2 on the left and 1 on the right. Hallelujah, praise the Lord. So let's rewrite this equation now after we canceled out all the crap that we could. So my new equation is 4 cosine cubed x sine x plus 4 cosine x sine cubed x equals 4 cosine x sine x. Okay, again, these first 2 terms were what was left on the left-hand side. Okay, let me scroll back up a little bit. And the last term here on the right of the equation is all that was left from the right-hand side. Now, on the left-hand side, I notice I can factor out a couple of things. So that's going to be my next step, is factor. So if I factor out the left-hand side, it looks like I can factor out a 4, a cosine x, and a sine x. So that's what I'm going to factor out. 4 cosine x sine x. So if I factor that out of both terms just on the left-hand side, I am left with cosine squared x plus sine squared x. Okay? Cosine squared x, let me scroll down to get out of my dead spot here. Cosine squared x plus sine squared x. And then the right side is still 4 cosine x sine x. Now, once again, what do we notice about what's in parentheses here? The cosine squared x plus sine squared x is my trig identity, which just leaves me with a 1. Okay, so anything times 1 is itself. So my final answer, hallelujah, praise the Lord, is 4 cosine x sine x is, of course, equal to 4 cosine x sine x. Now, this was kind of an odd example because it was a doozy, but you had to manipulate both sides of the equation to get them to kind of match up in the middle. That is not the typical case. Most of them, again, like I've said before, you manhandle the left side and get it to look like the right. This one, there was so much going on that we had to, do some algebra, some basic math operations on both sides. Okay, so this is going to conclude section 7.1, part C. I will do the last few problems in part D coming up.